Good morning, dear students. Welcome to this session on pre-stressed concrete. Last session, we have introduced the post-tensioning system. I'll just run through that first, then we'll talk about today's session. Okay. So, post-tensioning system is introduced in the last session, and class 13, you can go through all the uh, pre-stressing systems information from the IS code. And we have talked about stages of post-tensioning in the last session, a pictorial representation and a real picture of the post-tensioning operation of a heavy member. Okay, then stages, various stages of post-tensioning operation. Okay, advantages and disadvantages. Right. Today we'll talk about the devices required for or devices used in the post-tensioning system. Essential devices for post-tensioning are like you need to prepare concrete prior to tensioning. So casting bed is required and a mold shuttering, something like that is required, maybe a mold or shuttering. Ducts are required. This is additional requirement with respect to pre-tensioning and compared to pre-tensioning. Ducts are required additionally. Anchoring devices even in pre-tensioning is also required, but only for a temporary period, whereas anchoring devices in post-tensioning is a permanent device which will stay along with the member. Jocks are required for tensioning even in both pre-tensioning and post-tensioning, whereas here the jocks shall have a heavy capacity jocks. Couplers are optional to hold the bars together. Grouting equipment is also optional when you want to grout it or not grout it. You have to decide on the basis of the grouting requirements. Okay, so this is the now need for the essential devices. So casting bed is common, mold is common, ducts are now the difference between the pre-tensioning. There is no requirement. Post-tensioning it is required. Anchoring device post-tensioning it is required and also will stay along with the member. Jocks required in both the cases, but in case of pre-tensioning the capacity is less. Post-tensioning heavy capacity jocks are required. Couplers and grouting equipments are optional. Okay, so just going through each and every item like casting bed, mold and ducts. Okay, so this is the sketch showing that. And coming to anchoring devices, which I was talking about in the earlier sessions also, which are very much crucial because they have to stay back along with the member till the life period of the member. Okay, which are very essential and crucial in transferring the pre-stress to the concrete. If the anchorage device is failed, your pre-stressing member will fail. Okay, so this is the need for the necessity of taking care of the anchoring devices. So there are three types of devices, like based on their action, wedge action and direct bearing and looping the wires. So these three are the types of wedges, types of devices, anchoring devices. Working principles based on wedge action, based on direct bearing, looping the wires. Okay. Right, coming to first category, based on wedge action, how the or what devices are there, how they work, uh, all that we will talk about. Okay. So based on wedge action consisting of an anchorage block and the wedges. Anchorage block shall be there and wedges shall be there. Okay. The strands are held by frictional grip of the wedges. You have studied wedge friction in your friction chapter. So the some of the wedge action systems available. Fresnet uh, 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 anchoring device, Gifford Woodall system, Magnell Blatton system, Lee McCall system. Likewise, there are many such anchoring devices are there. Like I said, there are around 60 plus anchoring devices have got patented. Okay, so first comes the Fresnet system. It is now widely used in Europe and India. So India also uses these Fresnet systems. Consists of a cylindrical cylinder with conical interior. So this is something like this. So this is a conical interior. Okay, right. You will be drawing that in a line diagram. Okay. Anyhow, so that you have to. Uh, uh, these are just three-dimensional pictures, just to give you a clear idea. But you have to copy down the Fresnet drawing line diagram from the prescribed textbook by Pre-Stress Concrete by Yan Krishnaraju. Draw it and also bring the notes from the Krishnaraju, whatever explanatory notes that needs to be added to this. Okay, so if you want to say explain about Fresnet system, you have to draw a Fresnet system diagram and then the notes related to how the device works, what are all parts of the Fresnet system are there, right? Okay, so this is like what we call a conical plug. Okay, it is a conical plug. Okay, right. Okay, and cylinder, this is like the cylinder which holds this conical plug. Okay, so uh, the Fresnet T system anchorage cones. So what are all these? Like you see a slot here. So where the high tension steel bars will be placed in that slot. Okay, and similarly here. Okay, so likewise we will place all the HTS wires in these slots. Okay, and insert this into this conical cylinder. Okay, so the plug holds this, and there is a bar. Put it in the slot. So what happens? This is going to have a grip. Okay, and when the bar is being pulled, this is going to grip it with its friction action. Okay, so that is what is this. So the main advantages of the Fresnet system is a large number of wires or strands can be simultaneously tensioned using the double acting hammer. Okay, I mean double acting jock, hydraulic jock. Okay, so the set of these, okay, a cylinder and a conical plug. It's a simple technique, but works with perfection, like the patented devices. Okay, so a Fresnel devised a conical plug and a cylinder, okay, which can hold the bars in position, even though you apply 2000, 2500, 3000 megapascal stress into this wire, like that much of force, okay, stress into the area of such bar will give you that much of force, okay, so much of kilonewtons of force, even though it is applied. Okay, the rod will be held in position with this arrangement. That is the speciality of this Fresnel system, right? And a full-fledged picture of that Fresnel system. This is a strand which is cut here, and the wedge that is just shown like a conical plug is the anchor head. Okay, anchorage device head. The trumpet, something like sheathing cover. Okay, this is plastic sheathing which is holding this strands. Okay, so this is the full fledged diagram of anchoring device. Okay, and a colored picture of this. Okay, the same thing, a duct, bearing plate, the wedges, strands, anchoring head, connection, grout, everything. Okay, so this is the now as you will be drawing only the line diagram. So I suggest you to take the diagram from the Krishnaraju textbook. Okay, so coming back to Fresnel system, it's simple thing. So we are talking about wedge action. The device is working on wedge action. So there are many such devices work on wedge action. So where the Fresnel Gifford system and Magnell Blatten Lee McCall system. Some of the systems we'll talk about. Okay, so from which we have taken Fresnel system to talk about. So it is very widely used in India also, along with Europe. So we shall know about how it is working and what sort of devices are there in it. So there is a conical plug and the consists of cylindrical with conical interior through which high tensile steel wires are will pass through. These will be housed in these slots which are available around this conical plug. Okay, uh, by the wedge action by cylindrical conical plug lined longitudinally through these grooves. Okay, we have grooves here like slots. Okay, so through that grooves so many wires can be held in position and simultaneously. Okay, so the cylindrical mold is also of the type of where you can house this conical plug into that. Okay, so with the grooves to house the wires, so many, like, okay, variety of number of devices are varieties of there in are available in this also Fresnel system also, right? So advantages of this is, as I said, a large number of wires can be tensioned simultaneously using this double acting jock. Okay, so prepare the notes and have a diagram from the prescribed textbook. Okay, right, going for the next system. which is called Gifford-Woodall system. Okay, consists of a as you can see in the picture, there is a split cone available. This is the split cone, and a female cone is also available. Okay, these are the three-dimensional views, and the same are being shown in the cross section. So the split cone is shown in this cross section. This is the one, the split cone. Okay, this one is the split cone in cross section, and this is the female cone in cross section. Okay, and a bearing plate in cross section. This is a bearing plate in cross section, and the high tensile wire. This is the high tensile wire, which is running through that split cone as well as female cone and the bearing plate. Okay, so now so the each wire, only one wire can be no hold at a time, tensioned separately by holding it. Okay, and anchored by forcing a sleeve wedge into a cylindrical grip. Okay, uh, resting against the bearing plate. Okay, so what happens when you uh, pull this bar? When you pull this bar, what happens because of the friction here? This along with the wedge friction is going to stop that movement of the bar. Okay, that is how you are going to. And who supports these split cone and female cone? The bearing plate. They are resting against the bearing plate. Okay, so that's how it is going to work, right? So the ducts are generally formed by metal sheathing cast into the concrete member. Okay, these we use metal sheathing to provide the ducts. Okay, so this is how the Gifford system will work out, and you can see only one wire can be tensioned at a time. Okay, so the comparing with the previous and this one, the Fresnel system. Fresnel system, you can tension so many wires at a stretch simultaneously, whereas Gifford system, you can tension only one wire at a time. Okay, right? So just looking at this again, once again, Gifford system. So the different parts of this are split cone, a female cone, and a bearing plate and high tensile wire. Okay, so the high tensile wire, I mean pre-stressing steel, is inserted into the split cone, and split cone rests against the female cone, and the female cone rests against the bearing plate. Once the tensioning operation starts by hydraulic jock, by application of hydraulic jock, you apply the force in the on this tendon. Okay, so this tendon is gripped, okay, by this split cone, and the split cone is in turn gripping this female cone. The female cone is resting against this, you can see, is resting against this bearing plate. Okay, so that is how this tensioning operation works, and only one wire can be tensioned at a time. Whereas Fresnel system, you have so many wires to be housed, and then the tensioning happens simultaneously, right? So this is how the two different systems work. Okay, right? Anyhow, we'll talk about the rest of the systems in the next session. Okay.